This is my short ISP TMP36 thermometer final PCB in its case. This project uses a TMP36 temperature sensor, an Arduino Nano, and a 4-digit 7-segment display to read, convert, and display the temperature in Celsius. Note that the flickering is caused by the camera filming. Here's the thermometer reading a change in temperature, then freezing the high temperature, waiting for it to cool down before unfreezing it, and then reading the true temperature. The output voltage of the TMP36 is inputted into an Arduino Nano, which maps it out by setting the ratio of the voltage as a number from 0 to 1023, and then converting it to the same ratio of -3 to 150. Within the 4-digit 7-segment display, 4 segments in the same position share the same input. For example, the A segments all share one input. Then, to determine which digits are going to be high, the digit inputs are used. There is one digit input for each digit. This input acts as an enable, where when the digit pin is low, the digit will be off no matter the states of the segment. To allow each digit to display a unique combination of high and low segments, persistence of vision is used. For example, to display 46 on the first 2 digits, you change the segment inputs to output a 4. You enable the digit 1 input as high, add a small delay of a couple milliseconds, then turn the digit 1 input off. As soon as the digit 1 is low, the segment inputs are all changed to output a 6. Then digit 2 goes high, a small delay is added, and then digit 2 goes low. Within the code, each digit is controlled through this statement. In this case, we want to control the second digit, so D2 is enabled as high. Then, 4 statements are used to determine what number should be displayed. Let's say the temperature is 26 degrees Celsius. Since D2 is the tens digit, we want to display the number 2. First, a for loop is used to determine what the temperature is in Celsius. Int n starts as 0 and adds 1 every time the statement loops until it reaches a maximum of 40. Note that these values are going to be the range that the thermometer can display. Within the loop, an if statement is used, where if n is equal to temp and temp is less than 1, then go through. The for statement will loop until n is equal to 26, and in that case, the if statement will be true. Within the if statement, a conversion is used to equal the tens digit, which in this case we want it to be 2, where f is equal to n minus the remainder of n divided by 10, and then dividing that whole number by 10 again. Now that we know what number needs to be displayed on the digit, another for statement is used, where I starts as 0, adds 1 each time it loops, and its maximum is 7. Within the for loop, segment I is digitally printed as the state I, where segment pin I starts at A when I equals 0, and goes to DP or decimal point when I equals 7. State I is a combination of highs and lows that would synchronize with its corresponding segment to properly display the right number. This is done by creating a 2D array, where each row determines what number will be displayed, which is the value of f, and each column is the state of each segment.